This is a short and sweet concept on a rotating mass with angular momentum. It has some charge. The condition is that the charge and the mass are uniformly distributed. Okay, so we are taking 3 sums from AC Verma, the last 3 sums of the chapter, magnetic field. And the first sum is a non-conducting ring, and the charge Q is uniformly distributed on this. And the relation we are talking about is this: mu equal to Q by 2m L, where mu is magnetic moment, and L is angular momentum. Now we know that it is current into area. Here the charge Q is rotating with an angular speed, say omega, that's given. So what will the current be? Current is, Q by time period of rotation into pi r square, where this is the area. Now we convert that to omega, so it will become Q omega by 2 pi into pi r square. What is the angular momentum? It is I omega. For a ring, it will be mr square omega. Now if you divide mu by L, we get this famous relation Q by 2m. This is pretty useful. In JEE, they might give you a relation and work it out, one of the unknown parameters, you to work it out. But it is useful to know the concept behind it. Okay. So we did for a ring. Now this is sum number 50 from magnetic field chapter AC phenomena. Sum number 60 has the same sum with a plate, non-conducting plate. Now to derive this relation, you would need to take a small element of area and use integration, but that is a little long, so I will use a different concept. We know it is rotating around this axis. Let's take this point, which gives us the radius of gyration or gyration, as you may call it. Okay, and what is this point? This is the point at which the entire mass is assumed to be concentrated so as to give the moment of inertia. Okay, so moment of inertia is in terms of this radius called mk square. For a plate, it is, the k is r by root 2. Okay, the next sum is on solid sphere, which is root 2 by root 5 into r. So the same way we operate. Here L is I omega, so mk square omega. What about mu? Mu is I into A, and that is Q omega by 2 pi. And the area again, since we have now considered the entire mass on this circle, this area has to be taken with a radius k, so it will be pi k square, and you understand, if you divide it, you straight away get Q by 2m. Right? The next sum, 61, is on a is now on a solid sphere, right? And it is rotating above this axis with omega. Okay. Now again we take the center of, from the center, the radius of gyration, which is this point. The entire mass is seeming to be concentrated here, so it is rotating like this. So we don't have anything much to do. We know that I is again mk square, where k for a solid sphere will be root 2 by root 5 into r, and the angular momentum will be mk square I into omega. Mu again with the same thing, q omega by 2 pi into area. Area is now going to be this, what we have just envisaged here in terms of the radius of gyration. This is pi k square. So I did not even have to put the value of k. So mu by L again comes out to be Q by 2m. Fine? Short and sweet concept and very necessary. Right? Take it down.